Isagen Productive Energy. Sogamoso Hydroelectric Project. Isagen is a Colombian public utility company dedicated primarily to generating and selling electrical energy, positioning itself as the third largest power generator in the country. The company's infrastructure currently consists of 4 hydroelectric power plants and 1 thermal power station. Together, they have an installed capacity of 2,132 megawatts. Isagen's strategy is focused on expanding generation capacity to meet Colombia's growing electrical energy demands. As part of this strategy, the Guareno project began operations in August 2010. And currently, the Sogamoso, Amoya and Manso projects are under construction and are expected to be completed between 2011 and 2013. This video will explain the details of the Sogamoso hydroelectric project located in the northeast of Colombia in the department of Santander. It has been under construction since February 2009. The project worksite is located in the canyon where the Sogamoso River crosses the La Paz mountain range, 62 kilometers after the confluence of the Suarez and Chigamocha rivers, and 75 kilometers above the point where the Sogamoso River flows into the Magdalena River. The reservoir and dam are within the municipalities of Betulia, Girón, Zapatoca, San Vicente de Chucurí, Los Santos and Lebrija. These towns, together with the downstream municipalities of Barranca Bermeja, Puerto Wilches and Sabana de Torres, form the area of influence of the project. According to the project schedule, work will be completed by the end of 2013, when commercial operations will begin. Isagen's installed capacity will increase by 821 megawatts, whilst energy production will increase by 5,056 gigawatt hours per year, equivalent to almost 10% of Colombia's annual energy consumption. General description. The project consists of using the Sogamoso River as the source to generate electrical energy with the construction of a concrete-faced rock-filled dam and the installation of 3 power generation units in an underground station. Besides the dam, the main construction activities of the project are access roads to the work sites, including a temporary bridge over the Sogamoso River, a diversion system consisting of 2 tunnels to drain the riverbed in order to construct the dam, a spillway to control overflows during the operation, an intake structure through which reservoir water will flow, a headrace system consisting of 3 penstocks and a series of gates, an underground power plant with access tunnels and 3 caverns for transformers, powerhouse and oscillation, a discharge tunnel to return water to the Sogamoso River, a bottom outlet system to guarantee that environmental flow downstream is not disrupted while the reservoir is being filled, and 3 generator units with all the electrical and mechanical equipment necessary for the plant to operate and generate electrical energy. Energy generation process. The energy generation process begins when the water stored in the dam enters the intake structure, crosses the headrace system and arrives at the 3 generating units located 155 meters below in the underground powerhouse, where the force of the water is used to generate electricity. After passing through the power transformers located in an independent cavern, the energy is transmitted to the surface via a vertical cable shaft to connect to a substation. Once the water has been used for the process of energy generation, it goes to the oscillation cavern and from there is returned in its totality to the Sogamoso River. River diversion system. In order to build the dam on the riverbed, the river must be diverted through two concrete-lined tunnels. (11 meters in diameter) and 830 and 860 meters long respectively. These tunnels, which can support overflows from the river, return water immediately downstream from the project to preserve natural flows. Dam. The concrete-faced rock-filled dam will be 100 meters high, 345 meters wide at its highest point, and nearly 500 meters in length. The volume of the dam will be 8.5 million cubic meters. Reservoir. From the date that the diversion system is closed, the reservoir will take 3 months to fill up and reach its operational level. During this period, the bottom outlet system will be in operation. This structure is designed to guarantee proper downstream environmental flow in compliance with the project's environmental license. When the reservoir is at its normal operating level, it will occupy approximately 7,000 hectares with a volume of 4.8 billion cubic meters of stored water. A 100-meter wide ecological protection zone will be established around the reservoir to preserve the region's flora and fauna. The El Ramo stream will connect this protected area to the Serranía de los Jadiguillas National Park. Spillway. The spillway is a concrete passageway located along the dam's left side, and its objective is to drain the excess water produced by climatic conditions when the level exceeds the reservoir's capacity. The spillway is designed to drain the greatest probable overflows of the Sogamoso River. It guarantees dam stability and safety by preventing overflows of excess water. The water is returned to its natural course without causing any damage, thanks to the design of the deflector that absorbs the impact of the falling water. Intake tower, gates and headrace system. Water stored in the reservoir reaches the generators in the underground power station through an intake located 90 meters above the riverbed. And that consists of a concrete structure with a 110 by 25 meter grid. The water then passes through 3 penstocks that consist of a horizontal section more than 130 meters in length, a 95-meter vertical shaft, and then the lower horizontal section more than 180 meters in length. To control water intake, the upper sections of the 3 penstocks are equipped with gates that can be closed for inspections or maintenance work. The gates are controlled by means of 3 83-meter high shafts from an underground cavern that is 67 meters long, 12 meters wide, and 16 meters high, that is entered via a slip road that breaks off from the right shoulder of the current Barranca Bermeja-Bucaramanga road. Underground power station. After passing through the penstocks, the water finally reaches the generator units in the underground power station. The underground power station consists of 3 caverns for the transformers, powerhouse and oscillation. The powerhouse cavern is 142 meters long, 24 meters wide and 49 meters high. This cavern houses 3 groups of turbines and generators and the 3-story control building. An 8-story concrete structure is located inside this cavern also. The bottom level is known as the pump floor. The generator equipment is on the turbine and electromechanical equipment floors. The main floor is where the personnel arrive when they enter the underground station. The erection area and the control building are also located on this floor. The transformer cavern is 119 meters long, 14 meters wide and 16 meters high. The cavern was designed to independently hold the 324 megavolt ampere transformers in order to reduce the risk of damage to generator equipment from potential transformer fires or explosions. This is also the reason why the cavern is equipped with a 3.8 meter diameter gas escape vent that is 120 meters high. The third is the oscillation cavern, which is 100 meters long, 20 meters wide and 43 meters high, and collects water after it has been used in the electrical energy generation process. Description of electromechanical equipment. The generation process that takes place in the underground power station converts mechanical energy to electrical energy. This control process is accomplished through a series of devices, the most important of which are the turbine and generator. The vertical shaft Francis turbine is made up of several components. A spiral-shaped scroll case that enables the uniform flow of pressurized water around the distributor. The cylindrical valve that can cut off the water flow into the turbine. The movable blades and their hydraulic operating system. The speed regulator. The turbine runner that turns with a vertical shaft that has a guide bushing to avoid eccentricity and that is attached to the lower shaft of the generator. The draft tunnels, which carry the water to the oscillation cavern once the energy generation process is complete. The generator is mounted above the turbine's vertical shaft. Generator parts include the rotor, the excitation system and the stator. This is where the electrical energy is generated. Discharge system. After water is used to generate energy, it is returned to the Sogamoso River at a point located below the dam by means of a discharge tunnel. This tunnel is 223 meters long, 17 meters high and 14 meters wide. The river then continues its normal course until emptying into the Magdalena River. The ecosystem of the lower Sogamoso River is therefore preserved thanks to specific measures taken by Isagen. Environmental management. Isagen's environmental management is in accordance with current laws, the company's environmental policy, the environmental management plan of the project, and complementary environmental management plans. In addition, Isagen is committed to the development of the area of influence of the project by means of interactions that contribute to environmental protection, social development and economic growth. Re-establishing living conditions and replacing infrastructure. Isagen has designed a program to re-establish the living conditions of the population in the area of influence. The program benefits 222 families identified from the socio-economic census carried out in 2008. 6 new schools will be constructed to replace the 4 schools that must be relocated. The program also involves relocating some families who participated in choosing their new place of residence, providing a plot with an equivalent area to that which the families previously owned, but no less than 5 hectares. Constructing houses as required, offering guidance for replacing production activities or employment, and providing psychosocial support. This process represents an opportunity to improve the living conditions of resettled families, considering that the new houses will be equipped to receive basic utility services and will be located close to existing roads. In addition to serving the population that lives in the region, the infrastructure projects described below will also be undertaken. A section of the Bucaramanga-Barranca-Bermeja road near the dam is within the area to be occupied by the reservoir. It will be replaced by a new road between the Capitancitos and Linderos sectors. This road will have improved specifications. Instead of being 15 kilometers long, the proposed construction will be 11 kilometers. It will pass through 2 tunnels, one of 1 kilometer and another of 250 meters. There will also be 6 bridges of up to 160 meters in length. The design will allow for the road to be expanded to 2 lanes in the future. A 25-kilometer section of the road that connects Bucaramanga to San Vicente de Chucurí from La Renta to La Cananá is also in the reservoir zone. This will be replaced by a new road that will run parallel to the current road between Lisboa and La Cananá. In addition to better design, this road will also be surfaced. The proposal for this road includes 5 bridges, one in El Tablazo, where the current road crosses the Sogamoso River. This bridge will be more than 560 meters long, distributed in 5 spans over the river and supported by columns of approximately 110 meters. The project will also build access roads to the Montebello and Peñamorada sectors. The Gomez Ortiz and Giovon Lengerki bridges, which at the present time cross the Sogamoso River, are also in the zone to be occupied by the reservoir. An appropriate solution will be found to ensure the community's transportation needs. 15 kilometers of the Galan-Chimita pipeline, which crossed the future reservoir site, will be replaced by a new pipeline of 21 kilometers. Nearly 11 kilometers of power lines will be rerouted alongside the new Bucaramanga-Barranca-Bermeja road to facilitate maintenance work. We have now seen the essential parts of Isagen's Sogamoso hydroelectric project and some of the steps that have been taken to conserve and also develop the region. With the Sogamoso hydroelectric project, Isagen once again demonstrates its commitment to sustainable development in Colombia by providing productive energy to meet the growing power needs of the country and the continent. Isagen, productive energy.